Hello guys, I'm Romeo Galiarte from Taguig City University, and I'm here to show you how to prove an equation using replacement rule. But first, what is a replacement rule? Replacement rule is a logical system that may be constructed so that it uses either axioms, rules of inference, or both as transformation rules for logically expression in the system. Now that we define replacement rule, let's proceed now to see what are the components inside replacement rule. Replacement rule. There are so many, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10, I guess, more. But these are the commonly used replacement rules components in discrete mathematics. First one, commutation, association, distribution, De Morgan's law or De Morgan's, double negation, transposition, material implication, material equivalence, tautology, and exportation. Now, let's but before anything else, I would like to apologize about the whole image thing. I guess I'm too lazy to type it all one by one in a PowerPoint presentation, but I use this image to see you, for you guys to see what is the exact copy that we use in discrete mathematics. No more, no less. Just ignore the picture and focus on the details. First one, let's begin. First one is commutation. For me, commutation is simply the changing of places between variables. As you can see, PVQ is logically equivalent to QVP. They simply switch places, P and Q, Q and P. The next one is association. Association is also simply switching of places, but it involves 3 or more variables, and take note, it includes grouping symbol like parentheses. The next one is distribution. Distribution is just like how we distribute numbers and variables from mathematics. Just simply multiply it one by one inside. And the next one is De Morgan's law. De Morgan's law is simply it's just like distribution, but it adds up a little twist. The negation sign is simply distributed in each variable, and the operation symbol is changed into its reverse form. So the reverse form of OR is AND, so it changes. The next one is the double negation. Double negation is simply just like in mathematics too. When we have two negative symbols, it became positive. So negative times negative is positive. Now transposition is it's just like switching of places too, but it includes the negation sign. As you can see, P implies Q, logically equivalent to Q implies negation P. They switch places and negate the letter P or the variable P. Same goes to material implication. P implies Q is logically equivalent to negation P or Q. It changes its operation from implication or implies to or, and it ends up negation symbol. And material equivalence is it's this P and Q. PQ is logically equivalent to P implies Q, grouping symbol, and Q implies P. While tautology is simply just like multiplying or adding Just self to it. No, no, no. Multiplying is the right term. In variables, huh? Multiplying, um, multiplying itself to 1, I guess. So P or P is equal to P, and P and P is equal to P. So we all know that in logic, when 1 times 1 or true times true, true and true is equal to true, and false is false. True or true is true, something like that. And next is exportation. Exportation is P implies Q, no, P and Q grouping symbol implies R. Exportation is involves the changing of operation and extracting what's inside, or switching places rather. Now that I have already explained each and every replacement rule as far as I know, let's now choose one replacement rule so that we can proceed to proving. Let me see. Commutation, association, distribution. Let's proceed with transportation. Transportation rule. Sorry. It's not transportation. It's transposition. I don't understand it. Sorry. And remember, it's transposition rule. Transposition. Next. And now we will prove the transposition law as we choose it later, a while ago. The equation Q implies negation P is logically equivalent to P implies Q. This equation is from transposition law. Now we will prove it. Let's see if it will be equivalent to one another. The very first step in proving an equation is write the given. So don't forget the word given. You should always write it. For us, it's counted as a point when we have exams. So it's not a bad habit if you write the given and the number, right? It's just an additional option. The next one is use material implication in P implies Q. In P, the material implication is substitution or changing the changing from implies to or and add negation. It's material implication. Then we uses commutation. Commutation Q or P, Q or negation P. As I've said a while ago, commutation is simply the switching of variables. And that's right, switching of variables. And lastly, we use again material implication. Oh, see? And when we already got the same value or the same equation as the first equation, that ends the proving of an equation. And now thanks for watching. My partner Macy will continue the proving of equations in other examples. Thanks for watching. God bless.
My name is Macy Morales. I'm here